This is the answers to the question that's in the slides. So we've got the equations for redshift in terms of wavelength, redshift in terms of speed of galaxy and speed of light, and Hubble's law, or the Hubble-Lemaitre law with Hubble's constant, 2.3 times 10 to the power minus 11. Okay. So looking at the first one here, a distant quasar is observed to have a wavelength which is 20 nanometers longer than the same line. So the lambda at rest is 486 nanometers. So the observed lambda must be 20 nanometers more, which is 506 nanometers. And we're trying to find out Z, which is the observed minus rest over the rest wavelength. So we've got 506 minus 486 over 486, which is 20, funnily enough, which is what we had from the question, is the difference. So 20 divided by 486 gives an answer of 0.041, or an extra 1 for your 3 significant figures. And that is your answer. There's no units for redshift. Okay, for part B, going to use that value for redshift in this here, so we've got 0.0411 for the redshift, and we're trying to find out the speed of the galaxy, v, but we also know the speed of light is 3 times 10 to the power 8 meters per second. So we're using redshift equals v over c, so 0.041 equals v divided by 3 times 10 to the power 8, and so v is equal to 0.0411 times 10 to the power 3 times 10 to the power 8. And by a complete coincidence, if you keep the value for redshift in your calculator with the full number of significant figures, you get this coming up on your display. So you get 1.2345679 times 10 to the power 7 meters per second, which is so close to what would have been a really entertaining answer. So we'll just call that 1.23 times 10 to the power 7 meters per second. For the last question for distance, we're then using v equals Hubble's constant times the distance. So in that case, it's the speed we do know is at 1.23 times 10 to the power 7 equals Hubble's constant, which is 2.3 times 10 to the power minus 11 times the distance. So d is 1.23 times 10 to the power 7 divided by 2.3 times 10 to the minus 11, which gives a value of 5.37 times 10 to the power 24 meters.